Hello, I think we're live now. So we're back here with another little stream. I was just doing my thumbnail for this one actually. And we're gonna start coding in just a second. Let me just open some music so I can actually have a nice little chill here. And I'm gonna run this. Okay, hopefully it's not too loud. Yeah, I think this is fine. There you go, much better. Let me turn it down on my headset now. And also, let's start up the little program that gives the credits for the song so I don't get striked, basically, by YouTube. So... cool. And here we are, so... I think everything's fine now, so... right. So what are we doing in the stream? First of all, I've got my little hot chocolate here. We're gonna continue cleaning up from where we left last time, and I can't really remember what we did last time, but what I do remember is that we started to clean up some code, and we noticed that the code that was generating the square waves wasn't actually generating a square wave, it was generating a sawtooth, if I'm not mistaken. So we fixed that. And yeah, basically let's continue that work. So let me open up my project. And let's hope that nothing got broken from the last time we touched this. And if you're watching this in the future as well and you want to chat to me in real life and in real time, I guess, make sure you join our Discord channel. The link is on the website, on the YouTube header. So if you go on my YouTube About section, you'll see a little link to my Discord channel in there. So feel free to join. I do give out free help, and everyone in the Discord channel seems to be pretty helpful as well. I do enjoy talking to the guys in here. So yeah, let's quit that for now because I don't want to use a lot of RAM. So yeah, I mean, I don't actually know if we even pushed the stuff here, so I can see that we haven't. Let's just start by taking the diff. I don't remember, I can't remember what I changed at all. So, oh yeah, so we added the flags, of course, to the main CMake lists. So the compiler is essentially going to throw errors whenever it sees something that's perhaps undefined behavior or not quite right in terms of you know, modern and safe C++ code, which is fair enough. That's what we wanted, right? So I'm gonna add this little file here. So I definitely want to push these changes. Let's see what else we did. We changed the CMake list for the audio library, and I can't remember very well what we did. Oh yeah, we added the compiler options, and we did the same thing for the audio demo exe as well, that uses that, like the audio library that we created in CMake. So what I'm going to do is just add those two changes. So in my case it's number 1 and then number 4 here. Now, I'm not sure if there's anyone watching this, but this is a very neat way of basically adding up a bunch of changes to your Git repository. So if, for example, you've got, you know, you've done your Git status and you realize that you've modified a bunch of files here, and you basically, instead of copying the path to each one of them, what you could do is you could do a git add -i, and I'm hoping that you guys can see this. There you go. And then if you do git add -i, this essentially gives you a very nice and neat CLI interface here, where you can do a bunch of different Git operations very quickly by selecting one of these options. So for example, you can update a file by typing 2 or the letter U. You can see the difference of a file by pressing 6. So for example, if I'm not sure whether I'm going to push all of these changes, I can type in 6, and I also can now name, or I can number the diffs that I want to see. So for example, I want to see the difference in the CMake files 1 and 3, and you'll show me everything in your favorite code editor here. So in my case, in the CMake list, I can see the difference is the compiler flags that I added, and in the other file, audio demo exe, I can see the difference was also adding those compiler flags to my target, and that's it. And those will show you the differences that you've sort of staged. And if you want to check the status, you can press 1 as well, and it will show you everything here. But what is interesting for us is that I actually want to add or update the all of the changes that I've done currently. So what I can do is I can press either 2 or the letter U, and then I can say I want to now include, I want to stage now, or which will be the equivalent of git add and then the file name. I want to stage, let's say, this change here to audio.cpp. Maybe you'll forget about that one for now, but I definitely want to add the changes to the header audio file, and then the main file. So all I do is 2 space 3, and the star here represents a stage. So essentially, type in enter again, quit it. If you do get a status now, those files will have been added to the stage files that you can now commit, essentially. That's a very nice and neat way of working with Git very quickly on the terminal in a more visual way if you want to see what you're actually doing. I left the changes on the source audio.cpp here because I actually want to see what we did, to be honest, because I can't remember. This was a big refactoring, I think. So of course we renamed the struct from PA to stream data to audio queue. Right? Yeah, that's what we did. And then we fixed some of the compiler warnings that were being thrown as errors, I believe. And before we go anywhere, let me just open my WhatsApp here so I can see if anyone's messaging me. Okay, cool. We're free. And yeah, some more compilation errors that were fixed here. Just type conversion stuff as usual, and then renaming work. Okay, cool. So in this case, I am going to actually add that file. I'm going to commit everything and push, basically. Okay. So everything is now committed. I can push it as well. It doesn't really matter if I push it now. Cool. And let me just check the quality of the stream before I do anything, because I want to make sure that we can hear everything properly. There you go. It seems to be all fine. Hopefully you can hear me. It's just really good. Okay. I'm not sure about the quality of the camera, actually. Is it better like this? There you go. Turn on the white light just in case, so you can see my true face. Right, music is back now. And yeah. I'm going to turn the music up a little bit as well, because I know... Yeah, there you go. Just so you can hear the music a little bit better. So Cool. So let's continue. I think one of the things that I wanted to do last stream was to actually clean up this main.cpp file a little bit, and especially have a look at the main logic of the program and see if there's anything that we perhaps don't need, or if there's anything that we can simply simplify or just delete, really. So the idea for playing the song is that we would have either an array or a vector of these notes, and then the time that they will play for. So I think this is fine for now. I don't want to change this yet. And of course, each note has a note ID and a time in milliseconds, which is, you know, kind of represented by this array here. You can kind of see how you'd use something like that. And then the note IDs here. I believe there was also a function somewhere to actually go from a note ID to a sort of frequency, yeah, which is this function here. And this is actually stored using a static unordered map, which is fine. I mean, ideally, this could be something like a context per map in the future, because obviously this is created at runtime, but you know, it doesn't really matter too much right now because we only initialize this once. That's fine. I mean, let's leave it here. And then when you're given the note ID, we spit out the actual frequency for it, if it's available. If it's not, it's a null opt, or yeah, a null optional. Cool. Yeah, of course, we did some work on this create square wave last time, where we actually sort of fixed it. So yeah, we have a lot of magic numbers kind of going everywhere, really. I guess here I'm assuming the frequency isn't zero as well, because it could potentially do an invalid operation there, you know, division by 0. Oh, maybe, you know, just for the sake of simplicity and safety. You know, if it's less than or equal to 0, those would be invalid frequencies, I guess. We simply return an empty vector, so perhaps this can be you know, an error or a no length or a no value or something like that, or locked. But for now, let's leave it as that. So yeah, I mean, this code basically assumes that make sure, in fact, that this calculation here is going to indeed work. We'll just change that to a float as well to make sure. I mean, this is a flow, never mind. The thing is, step is not even used, so you know, that's one of the things we can definitely remove in this code. Number of samples is used down here, and as far as I understand, not up there anywhere, so we can kind of just move it down here to closer to where it's actually used. Now, samples per oscillation. Yeah, we're having that division by 2 there, so what we could do instead is kind of samples per, instead of oscillation, we would do samples per value, I guess, right? Because this is, you know, how many samples you'd have in each, you know, 1 or each -1 part of the square wave. So let's do that. Then we don't have to do the division every time now. Samples. There should be an S there for the sake of being right. Yeah, so the logic here, if I remember well, is that we create a vector full of either 1s or -1s, and the number of these values that there will be in each vector depends on the number of values per, value, which is essentially, once you add the negative ones and the positives, you'd have a whole oscillation. So, half of that will be in the positive and half of that will be the negative, which makes sense. Now, okay, let's continue. I mean, this should definitely compile still, right? Because I've not changed anything. And please don't give me an error. Of course it did. Let's see, it'll probably have an undeclared identifier or something like that. That's problems. Samples per value. Okay. Okay, cool. So now we should definitely work, right? Okay, cool. Yeah, I'm fine with the rest of this function actually. The whole sound is here. We reserve the number of samples that we need. We do a times 10 actually. It should have been a plus 10. The reason why we put a plus 10 there is just so we don't undershoot and have an unnecessary growth of the vector. We don't undershoot, sorry. So say, a number of samples came out to be something like 20.5 for some reason. This is what this calculation, resulted in. Then half of that would be essentially 10 and 10, right? Yeah, so I mean, the way to fix this would be to make sure the number of samples would always round up, right? So taking the floor, the ceiling of that instead of just a static cast here. Okay, so let's actually do that, shall we? So I want to do something like the ceiling of this whole thing there. And do I have CMath here? I do not, so I believe that will take the nearest integer added, above. Let me just make sure though. Yeah, there you go. It's from CMath. Seal returns a static cast. A float. Not an integer. Huh. It's definitely going to give me an error, but we definitely want a ceiling, and maybe we want to static cast the result of that as well to an integer. I mean, we know that this is a positive, and we know that ms is also a positive value, right? Yeah, let's make sure that that's the case as well. If ms is less than or equals to 0, in other words, if the time given is no longer than, no bigger than 0, which shouldn't be really, it's not going to return anything meaningful. Yeah, I mean, this way we can make sure that this calculation will also make sense. I'm using 44.1 quite a lot, and this is basically representing the samples per second. So we can put context per here. The number of samples per second, samples. This would be a context per. I want to say integer, but am I using it as a float everywhere? Let's see. So float. Okay, so let's have it as a float then. Yeah, I think, if you want to keep the name shorter, we can actually do samples hertz, right, something like that. Yeah, because hertz simply means samples per second, I guess, right? I'll just keep it like that, actually. So everywhere we included essentially that value, we're going to swap it. Samples per second now. Okay, so we got rid of the magic numbers for the sampling rate. Oh, there you go, sample rate. That's what I could have done. Let's change that now, I guess. Wow. I'm going to change to sample rate or something, right? Okay, changed all of them. Okay, cool. Let's go back to that function then. Yeah, I mean, the rest is fine. Except, there's this here. This is kind of how many milliseconds there is in a second, I guess, right? Well, I guess we'll deal with that later. What do we have here after? We have the audio buffer size, and this defines the number of samples that our lock-free ring buffer is going to contain. Which, as you can see, 424100 is not even 1 second, right? No, it's not even 1 second. So we could actually, I think what people actually do in the real world is that they have a buffer that's sort of large enough to maybe hold a couple of seconds. That's what we can do. But again, I don't know where this number has been used. I mean, it's definitely been used here in audio as well. There you go. I mean, this is, you know, this is something that we can definitely definitely define here. So, you know, static const expr. Let's call it a std size t. Let's say it's an std size t. Sake of consistency, I think we use const expr after the types as well, because we're using const, I mean east const everywhere, so buffer size or audio buffer size. And you know, what's the nearest value of 2 that we can get? Is it 48,000? I can't remember now. So obviously 2 to the 11 is what we have now. Oh, it's 2 to the 14, isn't it? Yeah. So what we need here is something close to 44 or 44,100 times 2, which is, yeah, this value here. So we want something like this, you know. So what if we do 2 to the 6, 2 to the 18? That's overshooting. 17. I mean, this is a second and a bit, so let's go for this here. So this is enough to hold 2 seconds. And I guess, how many seconds does it hold? Let's see. It's 4100. Holds nearly 3 seconds. I'm fine with that. Okay. And obviously, wherever we're using that value, we're going to now have buffer size. Yeah. And by the way, they are floats, right? So this is how many bytes we're going to have in that view that we're going to allocate to the thing. So is that times 4 bytes. Which is this. So, you know, we've got this byte to MB. It's half a megabyte that we're allocating to our program just to basically hold the audio data. So I'm fine with that. Half a megabyte is fine. And again, in here, we don't need that anymore because now we have audio and buffer size. Cool. Everything should stay the same now. Nothing should change. Except it will. Let's see what the problems is. Volume 1 is treated as an error. So initializing conversion from float to integer. Yeah, it's what we said before. We probably need to static cast this now that it makes sense to an integer. And let's compile this and see. I mean, that warning is still there. Type unknown type, expected, unexpected. Huh? Sample rate, autoconst. Oh, right, this is interesting. What's the actual error here? Oh yeah. I don't know why I put this STD there. It's just static cast. Okay, cool. By the way, this is something that we should definitely look into in the future. Having a look at all the static casts and make sure that they actually make sense. because, you know, static cast sometimes can mean that you are doing something that you shouldn't be doing. Like when you cast from a floating type to an unsigned type, things can go very wrong there, for example. But yeah, I mean, we'll leave that to later and then we'll check it. What's going on? I think I just hit. Dude, what am I doing? My Vim just kind of crashed. Just undoing it until everything goes back to normal, I guess. Is it going? Yeah. Cool. No idea what happened there. Just compile again to make sure. Okay, so write to buffer is another function that I wanted to also look at. So this has actually been used in the main code here to actually write data to the buffer. One thing I don't like is taking in the source destination as non-const objects, but kind of need that because we are actually changing each one of those. But yeah, I mean, there's not much we can do. I definitely need to look at this logic here because I'm not entirely sure it's working properly, but oh well. Right. I think those are most of the functions in our anonymous namespace, right? So what can we do now? Let's actually look at the main function. What happens when the PortAudio is no longer referenced? Nothing, because we did implement everything fine, right? In terms of the unique pointers and the custom deleters. Let me just make sure actually. Backend destroyer, okay. This song is actually pretty good. Yeah, this seems fine. This seems absolutely fine. Cool. It's actually quite cold here today, so kind of freezing. So what do we do here? Okay, so we initialize the backend. We don't need these. This is just some testing code I had to check that the queue is in fact lock-free. Because in Boost you can actually call this function called is lock-free on your ring buffers, which essentially tells you if that particular implementation of the ring buffer is lock-free. So for example, I'm having a ring buffer of float, and I wasn't sure if it's lock-free completely, but it turns out that it is. In fact, if I just for the sake of you know, sanity, I'm gonna check it. I'm gonna put a breakpoint here, and I'm gonna run the code and check those values, because they should both be true, really, implying that, you know, our queue is indeed lock-free. And if you don't know why that's important in audio programming, I recommend you know, just googling C++ audio programming and watching the talks by, I think his name is Timur Doomler, I think his name is. He gives out very, very good talks on why it's important to have lock-free programming in audio callbacks. And what the hell is happening here? Oh, that's interesting, eh? Before we even hit any lines in the main. Okay, I have no idea what's going on. Seems to be an error within the Windows code itself. There's a Stack Overflow before we even... Are we perhaps allocating too much memory for our queues? That's what I'm wondering, to be honest. There's one way to test it. I mean, now that we've made that change in here, let's change this to whatever it was, 2 to the 16, right? I mean, 2 to the 14. It was his value. I mean, if he hits the line now that we know that the creation of the queue was just fine, so yeah, there you go. So it is exactly just that. As soon as I saw that Stack Overflow, I figured that maybe we're allocating too much data. And before we continue, let's actually check these values here. So they should both be true, implying that it is lock-free. Okay. Let's remove that then. And let's think of a way to, you know, basically have that big queue that we actually want. I believe that I'm creating this queue in the sort of stack manner. It's not really in my lock call, if you see what I mean. So S single producer, single consumer queue. There is a way to create the runtime, the queue at runtime, so that you don't allocate it on the stack. Right? I believe there is anyway. So what if I just do this? Leave that there for reference. Because that means I have to actually initialize it somewhere else. Yeah, so write to buffer. Essentially, you know, I don't need to say this is a stack allocated queue. What I do need to do though is to actually create those queues. Okay, so okay, yeah, so you can't create an empty queue, or you can't call the, I guess, the empty constructor, right? Yeah, that's what it says here, because it'll give you an assert. It's not runtime sized. I mean, I'm reading straight into the fucking SPSC queue from Boost and seeing what it's doing. I want to create a runtime sized, as it says here, queue. So how do I do that? So I guess this is what we want here. It's an explicit. So let's create it. So where do we have the data? Oops. According to the code I just read, this is one alternative. So let's see. It still asserts. Cannot use explicit constructor. Is this gonna work? Oh yeah. Okay, cool. So this seems to work, which is good. Right. And again, let's just put this here so we kind of know which one is which. Okay, now, because this is a runtime sized queue, in other words, it probably uses a malloc for the allocation. It's not going to hit that Stack Overflow anymore because the data is all going to be in the heap, right? So that's what we want. Another thing I want to do is check if this is still lock free, because I'm not sure if it would be now because it's not a it's not compile time structure anymore. So let's just check that. Let's compile this, and then again let's run this code. Yeah, so it is still lock free. Okay, no surprises there. I'm just making sure. You never know if it's one of those things where Boost may say, it's lock free as long as you allocate it in the stack for some reason. So it's good. I haven't actually read the documentation for it completely, by the way. I read just enough so I can use this code. Okay, but the thing is, the audio should still play. So let's hear the whole thing. Amazing, so it still works fine. And even with the bigger audio, it should still, I just recompiled again and just running it again, just for the sake of sanity really, and making sure that things work. Come on. One of the things I don't like about C++ development using VS Code on Windows and compiling C++ code using the MSVC compilers is that it takes forever for the debugging session to start, and I don't know why. So anyone at Microsoft is watching this and you can tell me why. Just let me know, because it does seem like it takes exceptionally long compared to developing on Linux and using GCC and GDB, for example. As soon as you start debugging session, you know, the program will start running. But anyway, so I don't know why I put this comment here. You know, but going back to the code, we now have a runtime sized queue where the buffer size is actually large enough to store, you know, 0.5 megabyte for each queue, left and right. So we essentially have just over 1 megabyte for the whole audio queues. That's about 3 seconds or so. We initialize PortAudio there, and we also attempt to start the stream, I guess. And if it doesn't start, we return -1, that's fine. And then we create a deck, so a queue for the whole song left, the whole song right, where I basically just copy whatever's on the left channel, yeah. Okay, so for each node, I add the whole vector to the queue. Yeah, that's fine. I mean, this is okay, actually. We could have a const there, because we don't really... Oh no, we can't have a const. Because we use the deck down here. Now this should continue flag is funny, because I can't remember the logic that I used here, but... we can try and figure out. So write to buffer returns me a boolean. It's true if it actually wrote stuff, and it's false if for some reason anything failed along the way. Cool. So if basically it's true if it's successful, if it's successfully written some audio to the buffer, right? That's the idea here. So ideally left and right written would be both true until there's no more audio. Okay. And left available and right available will basically tell me whether or not I can write to the queues now, right? Yeah, if there's space to be written. And queue ready test. Okay, this is interesting. Yeah. So I have this variable called queue ready. Again, I'm going to delete that code because I don't need it anymore. And this one here too. Queue ready is an atomic boolean that tells me whether or not the queue should be ready to be written to. And this is actually set in the callback, if I'm not mistaken. So whenever we read audio from the callback, from the queue in the callback functions, then we're going to set the value to true, right? So that's what we do. The callback here somewhere. Default callback. This is another very good contestant for my next refactoring, by the way. This code right here in this file. What am I saying? Yeah, so there you go. So whenever we read stuff from the queue, so when we don't return early, then we say that the queue is ready to be written to. Okay, cool. So why is that important? Let's go back to my main code. It's because when the queue is ready, so in other words, when it's true, yeah, I don't actually use that. anywhere, do I? Unless I use it, should continue, yeah. I need to figure out the logic here, man, because I don't know what I was trying to write. So basically what I'm trying to do here is was essentially to see, you know, we're not going to run anything. We're not going to write anything to the... We're going to wait until the queue is ready. That's what I was trying to say. How do we say that? Yeah, this definitely needs some more thought. Because I'm definitely not going to figure this out 12:22 midnight. Yeah. Essentially, I want to put a guard on, you know, all the code that's right into the queue, and nothing's going to be set until the queue is ready to be set. So I'm going to leave that for a later date. And this is wait for the audio to finish. I mean, this can be the final blocking call on the code, which is, you know, I'm fine with that. What if we don't do this? Like, is it ideal? Like, theoretically, gonna write, because the queue is so huge now, we are just gonna write everything in one go in this loop here, and then immediately sort of exit. Let's just see if the theory works out. There you go. So it does add, you know, quite a few things, and it doesn't finish all of it because this code is out now. So in theory, you know, our code works as expected there. So we do need a blocking audio call at the end if you want to actually play the whole queue. I mean, but aside from that, I think this code is fairly okay to understand, at least. I mean, there's some minor refactoring or type changing things that I want to do, such as when calling create square wave, probably need to return an optional for when we can't really return a value, in case, you know, these inputs are rubbish. But the rest of it seems okay. I mean, what I'm going to do in the future as well is have a look at the audio. Have a look at the audio CVP. We want to move out the callback stuff to the main program, because ideally the person that's going to be setting the audio callback will be, you know, the main code. The main code is going to say how he wants to fill the queue, or how he wants the queue to play the audio. Right? No, because I have a queue. Yeah, I mean the queue is for that reason, right? So whatever mixing code we have can input to that queue, and that queue will then be added to the lock-free queue. Yeah, no, that's fine. Maybe I leave the default fallback in the audio.cpp. Yeah, but there's a lot of stuff here, a lot of stuff that I definitely want to change. So let's actually recap so we can finish the stream today. So what did it change here? We obviously, you know, added more size to our queue, because size does matter when it's audio programming. And we also moved the ring buffer from compilation time to sort of runtime. In other words, we're not allocating the data anymore on the stack. We're doing that dynamically at runtime. In other words, we're allocating it on the heap. So that allows us to not have a stack overflow when allocating a lot of memory, essentially. So that was a nice little thing we spotted. And let's have a look at what we changed on the main, because that's actually the main file we looked at for refactoring today. And what did we change? We got rid of some magic numbers, although there's still more we can do. We applied some more input checking to the create square wave function. We removed, I guess, some white space there. Then we changed it so it samples per value, so we don't have to do the same calculation twice. We also removed some of the step functions, step variables there that we weren't actually using. There is this ugly static cast there that I want to basically add back. Oh yeah, it seems like we accidentally removed the whole sound reserve. So let's actually put that back. It was on create square wave, wasn't it? So we're going to reserve this number of samples, or this many elements inside our whole sound. Okay. So that was that. We added that back. Again, we move all this stuff from the SPSCQ from compile time to essentially runtime. This is more of that work. Let's remove that comment. Don't need it anymore. I'm also going to move this to the very top, I guess. Let's put all of the aliases at the top. No particular reason, just to keep it there. So yeah, so this basically had to turn into this because we're now using the different constructor for the SPSEQ, the ring buffer. We remove the checking code. Apparently there's white spaces there, which we remove now. And more magic numbers, okay. Not very productive today, if I'm honest. But at least we got to understand the code a little bit better, right? So I'm gonna leave this comment here because I have no idea what I'm gonna do in terms of making sure that the code waits until the queue is ready to be written to, until there's some space on the queue for us to write some more audio to it. So I'm gonna remove this one because I have no idea. Obviously this is stopping the stream because there's a big... Okay, so which line is this? This is slide 139. Is it 139? There you go. To make sure I remove all the white spaces too. Oh, there's still some in here after the sample split value. And any more white spaces that are left. Ain't beautiful. Let's, you know, again add all that stuff. And that is it, guys. I'm actually gonna, call it a night now. If you're watching this in the future, I hope that you at least kept working well with me, and maybe you learned something. You never know. But I hope you enjoyed this. So please, if you're watching this, subscribe to the channel, join the Discord channel, because I do give out free help in there. So if you're looking to learn C++ or programming in general, happy to help. And make sure you like it, and then subscribe to the YouTube channel again. So have a good night. Bye bye.